Hey, hello, everybody. Hey, this is going to be all the answers and explanations to the kinematics review quiz for this week for conceptual physics. Now, a lot of this material is just kind of taken together all of the week one reviews, 1, 2, 3, and 4. And in each one of those reviews, there is a YouTube video like this one that is going to explain all those things. Now, in number 1 and in number 2, it was kind of a little bit simpler, and then in 3 and 4 we added distance, and in 4 we added gravity, so that complicates things. But we've kind of added all these things together, and if we look at these 4 basic equations that you saw in review number 3. These are probably all the ones that you need, and if you start with these and then move on, then you can kind of answer all these questions. So I'm going to kind of go through all of these review questions, and you can kind of see the step-by-step. So in questions 1 through 5, again, we have one setup, and then I ask you a bunch of questions about that one setup so that you don't have to keep redoing everything. So we're going to start the 3 competitors in a 1,600 meter race. So if you go out on the track and you run 4 laps, that would give you 1,600 meters because each lap is 1 meter. Okay. And the first runner runs the first lap in 70 seconds, the second lap in 78, the third and fourth laps in 76. So if we add up the total time, and this is going to be some of those questions in the in this quiz that they can be pretty easy. So we're going to take a 70 plus 78 plus 76 plus 76, and we're going to get a total of 300 seconds, okay? So number 1 there was just 70 plus 78 plus 76 plus 76 gives us 300 seconds. So that is equal to the time. Now, this right here is going to kind of help us out. For some of the other questions. What is the average speed for the first runner's entire race? Okay, and we're actually going to go right here, okay, in the equation number 1, and we're going to get average velocity is equal to distance divided by time. And therefore, we are going to say 1,600 meters, and we're going to divide it by 300 seconds. And so 1,600 divided by 300 is going to give us 5.3 meters per second, okay? 5.33 meters per second, okay? And that is equal to the average velocity for the first runner. Okay. All right. Which lap was the first runner's fastest? Well, if the laps are all the same, and they are 400 meters, then the lap that has the least time is going to be the fastest. And so for question number 3, that would be the first lap. Okay. Question number 4. The second competitor has an average velocity of 5.71. How long would it take for the second person to run 1 lap? So we're going to take this same equation right here. Again, that's without this part. And we are going to use that, but we have to change it around a little bit. So for question number 4, we're going to have average velocity is equal to displacement divided by time. Now, I am asking you guys for the time. So algebraically, we're going to multiply both sides by time, and then we're going to divide both sides by average velocity. And we're going to end up with this equation that time is equal to displacement divided by average velocity. Okay, so in this case, we are talking about an average of 5.71. So we're going to have a distance of 400 meters divided by 5.71. And 400 divided by 5.71, which is going to give us 70 seconds. 70 seconds. Okay. All right. So now we're going to have question number 5. And again, this is going to be a variation. This is going to be a variation on this question. It says, if the third runner does not finish the race, but ran for a time of 200 seconds at an average velocity of 6 meters per second, how far did they go? So again, we're going to have average velocity is equal to distance divided by time. And we want to solve for displacement. And so if we have average velocity times time, that's going to be distance. Notice that we just algebraically divided or multiplied both sides by t. Okay, so now we're going to have 6.0 meters per second times a time of 200 seconds. And we're going to end up with 1,200 meters, which is going to be our displacement. Okay, so that is the answer to the first 5 problems in this review. So now we're going to switch to the next setup. So I'm going to pause here for a minute and set that next part up, and we'll move on. Hello, we're back with that second section. And as I read this, the race car starting at rest increases its velocity to 20 meters per second in 5 seconds. Okay, so we want to calculate the acceleration of the car. So we're actually using this equation. And if you think about the part 4, I had g in there. And if we just dropped, the acceleration would be that of gravity, which is 10. But this is going horizontally, so we don't have to worry about that. So remember, we are trying to figure out, to identify what you're looking for is a big part. So we want to calculate acceleration. So remember that your equation has to have the variable in the problem. So we cannot use equation number 1 because it doesn't have acceleration in there. So we obviously, the rest of these have acceleration in them. So we want to look at some of the other things that we have in here. And we know that the initial velocity is equal to 0. We know the final velocity is 20 meters per second. And we know that the time is equal to 5 seconds. So from this material, we want to figure out what the acceleration is. And notice that we do not have distance here, okay? So we can't use equation number 2. And we have time, so we can't use equation 4 because that right there is giving us, it doesn't have time, so we need time. So, okay, so we want to know the acceleration. So sorry, we're going to use equation number 2. We're going to use equation number 2. So we're going to say V final is equal to V initial plus AT. So we want to get this all by itself. So we're going to subtract VI from both sides. So we're going to get V final minus V initial. Okay, that's equal to AT. And then we're going to divide both sides by time, and that's going to cancel out. so we're going to have 20 meters per second minus 0 divided by 5, and that's going to be 4 meters per second squared. And that is our acceleration, and that is question number 6. All right, so question number 7, it says at the end of part 2, what is the car's velocity? So because this is in steps, we know that the car's velocity at the end of step, or the end of part 1, which is the beginning of part 2, is going to be 20 meters per second. So our initial velocity is equal to 20. And our final velocity is what we're looking for. And we know that in the second part, it's got an acceleration of 2 meters per second and a time of 3 seconds. Again, we have the same variables here, except we're just trying to solve for v final. So we're going to set up the same equation right there. V final is equal to v initial plus at. And now we have an initial velocity of 20 meters per second plus an acceleration of 2 times a time of 3. So 2 times 3 is 6. And this is meters per second squared times seconds. And you'll notice that those sort of cancel out. And this is going to give us 6 plus our original 20 gives us 26 meters per second. And that is our final velocity. So now we are going to take a look at the next question here, which is going to be question number 8. And question 8 says, what is the final velocity of the race car at the end of part 3? And it says for the third part of the journey, the car has an acceleration of negative 5 meters per second, and it starts at 26 meters per second, and it comes to a stop. So in question number 8, like some of these quiz questions are going to be, it's just kind of reading from the problem, and it says in there that the car comes to a stop. So question number 8, the final velocity is just going to be 0 because that's just what the question is saying. All right, and question number 9. How much time does it take for the car to stop in part 3? Okay, so we need to find 3 variables, remember? So we've got our initial velocity of 26 meters per second. We already know that our final velocity is 0, and we know our acceleration is equal to negative 5 meters per second squared. And we are looking for the time. So again, you guys, we're looking for, we have the same 4 variables. So we're going to say v final is equal to v initial plus at, except this time we are solving for our time. So we can rearrange this. So we're going to move the vi over. So we get v final minus v initial. Then we can divide by acceleration. And so we're going to get 26 minus 0 divided by 5. And when we go 26 divided by 5, we're going to get 5.2. So it's going to take 5.2 seconds for the race car to come to a stop in part 3. All right, so that is the second scenario that we have in in this quiz, and that's going to be kind of how the the quiz is set up. So notice that we're kind of solving for one situation so that we don't have to redo everything. All right, so I'm going to pause this and we're going to set up the third part. So see you in a second.